morning one and all. I am Dr. Ramya Swetha, Assistant Professor, Department of Civil Engineering from Institute of Aeronautical Engineering. Today our lecture is on crack grouting and compaction grouting. So as a part of ground improvement techniques, this is the one of the important understanding the crack grouting and compaction grouting. So in this grouting techniques to modify and improve ground properties, we are using this crack grouting and compaction grouting. Coming to the crack grouting, injection of grout into cracks in soil or rock to fill voids and strengthen the material. Whenever the small cracks are there that may affect the strength or stability or any property of the structure, we are going to use this type of groutings. And also before construction also, any sort of soil disturbances are there, they may improve their properties by using these grouting techniques. We are going to inject these grouting techniques and we are giving the desired properties of the soil for better infrastructure. In that, whenever the cracks are there, we are going to fill those kinds of voids and strengthen that particular material. Such the type of grouting is known as the crack grouting. And whenever the injection of stiff, low mobility ground into the ground to compact and densifies the loose soils, such type of grouting is known as compaction grouting. In these techniques are essential for good ground stabilization, structural integrity and mitigating settlement issues. So these both crack grouting as well as compaction groutings are for better improved properties, giving the better improved properties to the soil for and it meets to the construction purpose. So in this, coming to this crack grouting, fill and seal cracks and voids in soil or rock, improve the structural integrity and load bearing capacity of the ground, reduce permeability to control water flow and prevent seepage, stabilize rock masses and soil structures. These are the objectives of crack grouting. In this type of grout materials for crack grouting is cementitious grouts, chemical grouts and various types of different types of materials. Those are going to available. Whenever they are required, we are going to choose this type of material. Each kind of material gives property to the soil. So coming to the cementitious grouts, Portland cement grout, commonly used for filling larger cracks, providing high strength. Whenever we require high strength, if we have the larger crack is there, we are choose this material. So Portland cement grout. Next one is the microfine cement grout, suitable for finer cracks due to smaller particle size. Next one is the chemical grouts, sodium silicate grout, reacts with soil particles to form a gel-like material, effective in sealing fine cracks. Whenever the expansion upon injection, filling cracks and voids effectively, those are all comes under these chemical grouts. High strength, durability, ideal for structural repairs. And next move on to the whenever the allows deep penetration into fine cracks and can be specific project requirements, the specific things we are going to need. Such type also we have to go these different types of materials we are going to use. Coming to the grouting techniques, low pressure injection, high pressure injection, sequential grouting is the different techniques for this crack grouting. Coming to the crack grouting, low pressure, high pressure and sequential grouting is required. In this low pressure injection, grout is injected at low pressures to avoid further cracking or damaging the structure. It is suitable for delicate structures or small cracks. It is applied whenever small cracks is there or very delicate structure, we are going to apply low pressure injection. Now move on to the high pressure injection. Grout is injected at high pressures to force the material deep into the cracks and voids. So whenever we are forcing, the pressure is more and the depth is also into the crack. It is also into depth of that particular cracks and fill the voids. Used in large or more robust structures where deep penetration is required, we are going to apply these kind of high pressure injections. Next one is the sequential grouting. In this method involves multiple stages of grouting, allowing grout to penetrate and seal progressively. So effective in complex crack networks or highly fractured zones, we are going to choose this type of grouting technique, that is sequential grouting. Coming to the design considerations for crack grouting: crack characteristics, grout selection, injection parameters. In these, width and depth, orientation and pattern. Coming to the grout selection: viscosity and setting time, strength and durability, and injection parameter: pressure and flow rate, volume of grout. These are the design considerations for crack grouting. Coming to the crack characteristics: based on the width and depth, size and extent of cracks, determine the type of grout and injection method. We are going to choose based on the how much size and how extend the crack and how it behaves. Also the thing for these characteristics. And crack direction, how the direction is there and how it is distributed after affecting the ground penetration and effectiveness also we have to consider at the time of the design for crack grouting. So this orientation and pattern is very important, and also on which direction the crack is equal to move and where it is placed and how the locality is there, which type of method, how it affects, and what is the desired property. These are all the things we have to consider in this crack characteristics as a design consideration for crack grouting. Now move on to the grout selection. In this, viscosity and setting time, choosing the right grout once we select to match the crack size as well as the environmental conditions also. Ensuring the grout provides adequate support and longevity, and also we have to ensure about the strength and durability also based on the grout selection. Now move on to the injection parameters, controlling these to ensure effective grout penetration without causing damage. So this calculating the required amount based on the crack volume and project specification, that is nothing but the volume of grout. So based on the pressure and flow rate, controlling and to assure effective grout penetration without any damage. The volume of grout, calculating the required amount based on the crack volume and project specification. So what are the various equipments and methods for crack grouting? Injection pump, mixing plants and monitoring systems. So low pressure pumps, high pressure pumps comes under these. Injection pipes. Coming to the mixing plants, batch mixers as well as continuous mixers are also there. And monitoring system, we are going to monitor the pressure as well as the flow meters. In these low pressure pumps, suitable for delicate operations and small cracks. Coming to the high pressure pumps, necessary for deep penetration in robust structures. Coming to the mixing plant, provide precise control over mix proportions for small projects. We are going to choose these batch mixers. Whenever continuous suitable for large projects, ensuring a constant supply of grout, we are choosing this continuous mixers equipment for the required crack grouting. The pressure essential for real-time monitoring and control of injection parameter. It is very, very important. As per the design limit, the process is going or not, we are going to monitoring. Coming to the quality control and testing for crack grouting, pre-grouting test, during grouting, post-grouting. Coming to the pre-grouting, we are going to consider crack mapping and their analysis, laboratory test of those grouts. Coming to the at the time of during the grouting, we are going to monitoring the injection parameters as well as record grout volumes. After post-grouting tests, visual inspection and coding, load testing we are conducting for understanding the quality of the crack grouting. And which we chosen, they are in the line or not, we are going to understand. So coming to the pre-grouting test, crack mapping and analysis, detailed assessment of crack characteristics, and coming to the laboratory test, we are conducting because ensuring the selected grout meets project requirements or not as a part of quality control. Now, at the time of the grouting, we are ensuring pressure and flow rates are within the design limits. Coming to the record grouting volumes, tracking the amount of grout injected at each point. Post-grouting tests are also visual inspection and coring, examining grout distribution and effectiveness, assessing the structural improvements achieving through grouting. Some of the case studies and applications of the crack grouting. Dam repair. Example, crack grouting in the foundation of a dam to prevent water seepage. So, what is the outcome? We are apply this crack grouting. The outcome is improved structural integrity and also reduced leakage. The next case study, tunnel stabilization. Example, sealing cracks in tunnel linings to prevent water ingress and enhance stability. Whenever we are choose the required material, apply the exact method using the correct equipment. What is the result of this type of case study? We are getting extended lifespan and safety of the tunnel. The next one is the building foundations, repairing cracks in building foundation to prevent settlement and structural damage. After applying the crack grouting, the outcome is increased load bearing capacity and reduced risk of damage. So this is the, till now we understand the crack grouting objectives and what are the materials we are using, what are the quality control test, what are the applications. Now move on to the compaction grouting. So densify and compact loose or unsuitable soils, increase the load bearing capacity of the ground, reduce settlement and prevent the further subsidence, improve soil homogeneity and stability. These are the objectives for this compaction grouting. In this, so cement based on grouts, various types of materials we are using for this compaction grouting also. In that, cement based grouts, sand cement grouts, clay cement grouts. So in that cement based grouts, stiff mortar grout, low mobility grout providing significant compaction and strength. The next one is sand cement grouts, used for maximum compaction and load bearing improvements. Clay cement grouts enhances workability and reduces the shrinkage. Grouting techniques for compaction grouting: primary and secondary injection, incremental injection, preloading and grouting. These are the various techniques for compaction grouting. In these, primary, initial injection followed by additional injections to ensure uniform compaction. For uniform compaction, primary injections followed by secondary injections to ensure uniform compaction. This type of injection, primary and secondary injection for compaction grouting, we are going to use or apply in large areas or complex soil profiles. incremental injection. This method, grout is injected incrementally in stages. The name itself tells incremental, and grout injected incrementally in stages to achieve gradual compaction. This kind of technique we are using to prevent sudden soil movement, to prevent the sudden soil movement. Preloading and grouting techniques. In this method, a preload to the soil before grouting to enhance compaction effectiveness. It is going to apply projects requiring maximum soil densification. So, these are the grouting techniques for compaction grouting. What are the design considerations for compaction grouting? Soil conditions, grout selection, injection parameters. In these soil conditions, soil type and density and also water content are the design considerations for compaction grouting. So, determine the appropriate grout type and injection method depends upon the soil type and its density. Ensuring proper mixing and reaction of grout depends upon the water content or percentage of the moisture content depend upon for compaction grouting. Coming to the grout selection, consistency and workability. Choosing a grout that can effectively compact the soil. Strength and durability, ensuring the grout provides long-term stability. Injection parameters, pressure and flow rate, controlling these to avoid excessive soil or fracturing. Calculating the required amount based on the soil void ratio and project specification. These are the design considerations for the compaction grouting. Coming next, move on to the equipment and methods for compaction grouting. Injection pumps, mixing plants, drilling ridge monitoring system. So in this, high pressure pumps are necessary for injecting stiff and low mobility grouts. Mixing plants, continuous mixers, batch mixers. Ensure a consistent supply of grout for large projects in compaction grouting. Provides precise control over mix proportions for smaller projects in compaction grouting. Drilling results, rotary drills, percussion drills. This is common for creating injection points in various soil types, and these types of drills are effective for in denser soil formations. Monitoring systems, real-time monitoring of injection parameters is important, and those depends upon the pressure gauges and flow meters. Quality control and testing for compaction grouting. Pre-grouting test, during grouting, post-grouting. In this, soil borings and density test, laboratory analysis of grouts comes under this pre-grouting test. At the time of grouting, monitoring injection parameters, record grout volumes comes under this during grouting. Density testing and core loading test, those are conducted at post-grouting stage. So these are all quality control and testing for the compaction grouting. In soil borings and density testing, assessing initial soil conditions as a part of pre-grouting test. Ensuring the selected grout meets project requirements as a part of pre-grout test. At the time of during the grouting, ensuring the pressures and flow rates are within the design limits. We have to understand during the grouts, and also tracking the amount of the grout injected at each point is also we are going to understand as a part of quality control and also testing for this compaction grouting at the time of during the period of the grouting. Now, Post-grouting tests. So these assessing soil compaction and grout distribution we are analyzing as a post-grouting test and also as a part of quality control also. Evaluating the improvements in bearing capacity. Loading tests also after post-grouting test. Case studies and application of compaction grouting. Foundation improvement. In foundation improvement, compaction grouting to stabilize loose soils, a building foundation. Its outcome, once we done this compaction grouting, the outcome is increase in load bearing capacity and reduced settlement. Case study which we consider in roadway and railway stabilization. For example, in roadways and railway stabilization, densifying soils under roadways and railways to prevent settlements and improve stability, we are apply this compaction grouting. It enhanced durability and safety of transportation infrastructure. Sinkhole remediation. Compaction grouting to fill voids and stabilize soils in sinkhole prone areas. Once we apply this compaction grouting, the outcome is prevention of sinkhole formation and protection of the infrastructure. These are the case studies. These are the some of the web references are available. Thank you. We will see in our next class.
Like, share and subscribe. Hit the bell icon for more updates.